Alrighty, we can go ahead and get started. First off, I want to say hello to everyone and thank you for joining us today for a day in the life with data science. Of course, we have two people joining us today to really dig deep and show us and tell us what data science is really like, what that looks like in your career, and even just how to get there and their experiences. My name is Camila Valentin, and I am the program manager here at the Knowledge House, and I am working really closely with our recruitment team for our program, as some of you may know. So I will plug in at the end again and remind you all to definitely check out our website and go ahead and apply for our program. Hopefully this series will kind of show you what will be best of interest of you. I know this week we have data science, but next week we do have progressive web development and UX UI. And the week after that, we will have cybersecurity as well. So I really hope you all enjoy this session and I get to see you all at the rest of those sessions. With that being said, I am more than excited to introduce two very amazing people, John and Janet, and I'll let them intro their styles, but John works with us as a volunteer here at the Knowledge House, and Janet was actually one of our alumni. So with that being said, I'll pass it off to them to just give a brief intro, and then we'll jump into some questions.
Well, yeah, hi everyone, I'm Janet. Let's see. So I graduated from the data science with Python fellowship just last September. So it has been a couple of months since I graduated from TKH. But before that, I went to Binghamton University and I got a bachelor's in math and bio. I actually worked as a math tutor and math instructor. And then I learned about the tech space, and thankfully I learned about TKH. And then now I am here actually just started as a software engineer at Bloomberg.
Okay, and I'm John Novotny, and I am the CEO and founder of patientsDB, which is a startup company that offers management and business intelligence to healthcare, specifically hospitals. I met the Knowledge House and specifically your CEO, Geraldine, going on almost 4 years ago when I saw in the Columbia University Alumni magazine a spread on Geraldine and what she was doing at the Knowledge House. And so I very quickly introduced myself to everybody over there and started working as a volunteer doing mock interviews. And I think it's been a very interesting opportunity for me to see how there's a lot of talent in the outer boroughs, in the Bronx, and then and now we're talking about Newark, Atlanta, Los Angeles. And for me, seeing the talent come along and get a chance to realize itself is very, very motivating to me. And that's why I'm here. And today specifically, I'm going to have a chance to tell you how patientsDB came to be and what it does with data science. And so I'll tell you about that during our meeting.
Awesome, thank you so much. There you have it, folks, two amazing individuals. With that being said, I'll jump into some questions, of course, because that's what we want to hear, right? What is everything, right? John, Janet, what is data science, right? What does that really mean? And how can we kind of see that in everyday scenarios, right? Like for me as a regular person who doesn't have so much experience with data science, what are some examples where I can kind of see that coming up?
Let's see. So I think of data science as like this combination. They call it like an interdisciplinary field that combines like math, computer science, technology, for really like the use of technology to analyze data, right? So I think of it as like it helps companies to make data-driven decisions. There's one example, I don't remember like the full details, so I'm just gonna share it, but again, I'm gonna go back and check these details, but I remember it was maybe Pepsi or Coca-Cola, one of those big companies. I remember reading that they created they put some vending machine, don't remember specifically what country, but what they were doing is that like people were able to create their own flavors, but the company was actually collecting this kind of data, and this actually kind of allow them to see what were some of like the what you call it, like not similar, but favorite flavors in particular parts of where they were putting these vending machines. So that's why they were able to create new flavors that came out. So they were able to do that. So like, I always think about that example of when I think about data science, it's how do you use the power of data to be able to come up with decisions for your business or for other fields, not just of course in business, but maybe John will have a better way of explaining it, or a different way to see data science.
Well, Janet, I like your examples, and I don't know if I have a better way, but I'll tell you what, I have a longer way because I've been doing this for a little while, since I'm now technically, I think, what they call an old guy. So my original exposure to data science happened when I was involved in a scholarship for medical school, and I was then involved in doing some scientific research. And that was the first time I began working day in and day out with PhDs, you could say, in data science, real scientists, real mathematicians. And this was something that fascinated me. I was always very much interested in basic science. I loved my undergraduate experience, and I loved mathematics and science. And when I got to work with real, you could say, data scientists, I wanted to learn how to do that myself, not just depend on, you could say, consultants. So that's when I had my TKH experience. Before there was a TKH, I wanted to learn how to program. And programming and data science and understanding data and understanding analytics, and then being able to, for example, come to conclusions, and what we were trying to do at the time to publish research papers, was all kind of a continuum. The data science and programming related to all that for me. So I jumped in and, you could say, self-taught programming. And I then ended up learning, you could say, data science in kind of a reverse engineering sense. You know, in other words, like a child learns to speak a language, I learned programming and data science in that learn it as you go method. And so that led to programming and statistical analysis. And then I ended up doing a degree in statistics. And then when I finally got back into my medical career back in the hospital, that's when I found what I call an ocean of data problems without a good solution, and lots of extremely overpriced, costly software. And that's when I started having my light bulb moments and started creating my own programs and using data science to create applications that we could use in the hospital on the job to manage our activities, our group, our department, and then also report on it in the sense of analytics, business intelligence. And that was just a long pathway of me coming into data science. And for me, the last thing I'll say about it is data science to me is about application development. And I know there's sort of a sense that data science has become something separate. And I think sometimes that's maybe even a stumbling point for some students looking at this and thinking, why would I want to get into something that seems so intimidating? And I'll just tell you that if I can do it and you're interested, you can do it too. I did it because I was interested, and I kept looking at the things that mattered to me and what I was meant to be looking into, research questions, or in the case of the hospital, where I ended up working then as an attending physician, I wanted to answer questions that nobody could answer for me. And I was getting kind of impatient with, hey, you know, what's the answer? For example, what's the return on investment of our cost center, of our people, of the patients we take care of? I wanted to know answers to questions like that. And they would tell me, well, we don't have answers to questions like that. And we don't really look at our operational activities that way. So that's when I started building patientsDB kind of on the job. And you could say I reverse engineered it to the point that it became a company. So that's my story.
I love that. Thank you so much. And that's perfect into our next question. Janet, if you could touch a little bit, John, you already touched a little bit on it, and you can definitely go into more. But when did you realize that tech was something that you wanted to do, right? Was it something that maybe you knew from a very young age, or is it something that you knew a little bit older, maybe just a couple of years ago? What did that moment look like? Was it something that sparked it? You could just tell us about that.
Yeah, so my role into tech was it's a little long actually. Like I know that I just finished TKH and now a couple of months later I'm working in a tech space, but I would say that it didn't start early on. Actually, when I was in college, I studied math and biology, and I thought I was going to go more into like the biology field, maybe working in a lab or something. But I felt like deep down, I didn't feel like that was the space for me. Like I just didn't see myself. At some point, I realized I don't see myself being a doctor or a nurse, but also not being a researcher in a lab. So I kept on asking myself, what else is out there for me? So then like little by little, I started hearing different terms, for example, like mathematical biology, bioinformatics, which is like the study of, it's like an interdisciplinary field as well that also combines like computer science, math, but for the study of biological data. So that's actually, I heard about it after I graduated from college. And I actually met a bioinformatician when I was volunteering the molecular pathology lab at Mount Sinai. And then after like talking with this person, it was very clear to me that I needed to learn programming to go into this field. And when I also learned about mathematical biology, which is, I think of it as like, a part of it is like using models to understand like biological phenomena. And that's something, having the science and the math background, it felt like it was a good fit for me. But based on my research, it seemed like I also needed to learn how to code there. So it was all these different paths that still took me to coding. So eventually I started learning how to code on my own first, but I felt like I wasn't doing it fast enough. I wasn't grasping the concepts on my own, and that's when I learned about coding boot camps and TKA. So no, I didn't even think about the tech space while I was a college student. So it was actually after when I realized that I wanted to go into programming. And then when I actually started with TKH, I was exposed to other things. Like when I went into TKH, I went into it thinking I'm going to go either into public health or bioinformatics. But then I met people there. I met like software engineers. I met data scientists. So I learned more about the tech space. And then that's when I started like exploring other possibilities other than like bioinformatics. And that's why I ended up here. So I would say it's kind of long because it didn't start like right after I started with TKH, but yeah, it wasn't until after college when I started really looking into going into the tech space. That's it.
Awesome, thanks. And this question is for both. You both have kind of shared kind of how you got to where you were, right? Getting into this. Is there anything that you would have changed about how you got to where you are now? Or are you totally 100% down with how you went through anything? Is there anything you kind of would have changed, maybe looking at it earlier on, or maybe taking a different pathway to get there?
Would I do anything differently? That's hard to say. I think that the thing I might have done a little differently is to pick up my own sense of how to learn new techniques without hesitating, without waiting. An example of what I'm talking about is there was a point where, well, for a few years when we were first building patientsDB, I was on the job as an attending physician trying to do that job and trying to then build this application up and up and up. And I regarded the engineers that I worked with as consultants who had their expertise that I may not. I would tend to leave it to them, leave the decisions or the knowledge about a lot of these design questions, these engineering questions that I think I assumed for either my sort of that sense of laziness of they'll handle it, or maybe I don't know, maybe just a sense of I don't need to do this now. But my point about that is there came a moment where we had to make some major pivots, as they call them in entrepreneur world. And I learned at the point of needing to make a pivot, what does it mean to pivot in a sense of an entrepreneur? And what that means is you have to know about some of the fundamental engineering or data science concepts to make decisions about whether your company or the application you're building, for example, is going to need to shift a platform to something entirely different. And what I mean, this goes back a ways to around the year 2000 or 2002. And what I'm talking about is at the time we needed to consider changing our platform from what used to be called, and still is called, I think, client server, which is a much heavier, much costlier, time-consuming way of serving applications than, let's say, a web application, which is much lighter and much easier to produce and the kind of thing that you're learning at the Knowledge House. So I think that I would have liked to have more fundamental knowledge like that earlier on. So what my message to anyone who might benefit from this is, when you're curious about something, just like what Janet was talking about a second ago, look into it, because your career isn't just going to be one straight line. Janet did a whole bunch of things that remind me of what I went through, and she's smiling, so she's happy with what she did. She's got a job at Bloomberg now, and that's what I like about my career, is what I think Janet was describing, which is look into the things that really interest you. If you don't understand it, just reverse engineer it from a problem you'd like to solve, study it, work backwards, see how the coding works, look at the data. And then after a day or two, or a week or two, or a month or two, you'll be like, wow, I'm starting to understand this. And that's a good thing, to invest in these, let's say, questions that you might have left unlooked into. I would recommend looking into it.
I mean, I guess as an undergrad, it would have been nice to study computer science. I think like math and computer science go hand in hand. So I think like that's definitely something that would have been very helpful. But I don't know. I don't feel like I would have changed anything about what I did. I think I had a path and I went in different directions. But it was because I went through those different directions that got me here. Like one of the things that I'm really grateful about going to TKH is through the people that I met. Then that's from the peers, from like TKH people there, and I would say the mentors were such a huge help. Actually, like meeting one of the TKH mentors here, who's a software engineer at Bloomberg, is the reason why like I even thought about applying to Bloomberg, because like we had that conversation of going to software engineer, and he he was so encouraging and really motivated me to apply to Bloomberg when I probably didn't really believe in myself at that point, but he really like, yes, you can do this. And also I also had other mentors that helped me and encouraged me to continue my journey. So I just feel like everything that happened up to this point, I think of it, it was like it was meant to be, and I learned so much through that process. So at least for me at this point, I feel like I'm happy with how things went. And yeah, I loved it. Yeah.
Awesome. And I really just want to highlight for everyone here just how different John and Janet kind of started, right? None of them started off saying, yes, data science is a field for me, right? This is what I'm doing straight from high school or like starting to college, right? It is something that came into them, right? As you're exploring your career, as you're exploring life. So I really want to highlight that, because it shows that tech is for anyone, and it doesn't have to happen at any moment in your life. It's not something you have to know at the age of 18, 20, 25, 35, 40, right? It's something that you can pick up at any moment. And it's something that there's so many pathways to really get there, and it all kind of touches so many like points of interest, right? Like we've heard Janet and John speak about how they got into it was just because of the things that interested them. It wasn't even them looking to see if this was the field for them. It just kind of drew them there. So I think that's really awesome to even hear and think about, especially when thinking about technology, just because it is a very very daunting career space for a lot of people, and just showing that, hey, like you can literally turn over one day and say, this is what I want to do. But at the end of the day, it all just takes, doing that research, right? And being passionate about it. So thank you for your insight about that. That was really inspiring. With that being said, can you all just share maybe a little bit about what your day-to-day looks like, and maybe about other job roles and opportunities that kind of exist in the data science field?
Okay. Well, right now I can't really share much because this is my third day with Bloomberg. So I'm just doing like the paperwork and onboarding. So that's pretty much what I'm doing. But maybe I could talk about my work that I did with Murmuration last summer, because that's more data science. So as a fellow, I looked at bias in the machine learning models that the data scientists built there. So so with Murmuration, they create these models called turnout score models. So the way I understood it is like they're predicting the probability of people coming out to vote. And if you don't know Murmuration, basically they provide like analytics and tools to people who are, sorry, to organizations that are trying to make a change in the public school space. So these turnout score models, basically they help campaigns see who are like the best people, or essentially the people who have the higher probability to coming out to vote. Because as you can imagine, campaigns are expensive and they want to make sure that they're using their resources as best to their ability. So my role as a fellow is to understand, using data science, to understand how the models were performing. And like I had to think about what metrics did I want to look at, what visualizations, how did I want to evaluate those models. So yeah, I ended up doing that. It was pretty cool because I got a chance to understand what they were doing, but also I also got experience through the technical work. Like I learned about just how to work with all these different tools, basically, that allows data scientists and software engineers and people in the tech space to be able to collaborate with each other. And I was like I was in the data science meetings every day. I had like code reviews. So basically, you show your code to the data scientists and they give you feedback on how you're doing. So that was a really great experience. So at the end, I was able to present the work that I did in the summer. So that was pretty much like my work during the summer.
Thanks, Janet. Next, I want to ask, where do you see the data science field going, right? And what should people be doing if you think this is something they're interested in, and what can they really expect, right? What are some things that you think people should know?
Okay, I'll go first on this one. What I see, what I would like to comment on is what I see the Knowledge House has constructed their tracks in terms of application development, and then you have data science. And the message that I'd like to give, based on my experience and the way we use data science, is that we don't draw a distinction, this distinction between these two things. Data science, in a phrase, is application development. I don't know how one would ever develop any application without data science. I'd like to know what application would that be that has no data science behind it, because I'm not sure what that would look like, besides maybe a pretty box or a light that blinks on and off or something like that. So to me, when I look at an application, I immediately start asking myself, what's in there? Where did this come from? Where did these conclusions, these answers you're seeing, or if it's a game, where did these graphics and these numbers and these high-speed graphics come from? What's informing it? And that is absolutely a data question. And because it's a data question, it's a data science question. So data science to me is about application development or design. If you're interested primarily in application development, web application development, progressive web app, I would encourage you to look at the data that informs the applications you're interested in, then work towards the data look at the data science behind it. And what I mean by data science is what are the techniques, the programming languages, the programs, the queries that are used to get the data that are informing that application. Now, if you're on the other side and you're much more interested in data science, let's say in the sense of classical or isolated data science, focused data science, then what I would want you to understand is that this has become an enormous field. It's absolutely staggeringly not so much, I don't want to say complex, it's rich. There's so much to study and to use as tools compared with years ago. And what I would say to avoid getting bogged down, or even to avoid potentially being discouraged by how much there is to learn, is look at the end point. Again, this concept of reverse engineering. Start with something that you love or that you're fascinated with. And it could be a game, it could be an application, it could be a question you'd like to answer about a business problem you've had or you've seen. Start with that one and work backwards to the techniques they use. Because again, for what we do, for application development, when we talk about an algorithm, what we're talking about is a business process that we've developed, or let's say an algorithm, a set of code that represents a business question or an answer to a business question. And these are sort of custom original algorithms that depend on data science. Now, if you go to more of an extreme of pure data science in the way it's thought of, let's say most recently, you're talking about machine learning, AI, and things like that, neural networks. And again, what I would say to you about that is pick the area that's of interest and then focus on it and work backwards from the thing you'd like to use or study, and then use those techniques. And you can, any place you end up working, as smart as the people might be, you can rest assured and comfortable that not one person in that place of employment will have mastered all of the things that you're looking at in your syllabus. Absolutely not. They all rely on each other. A person becomes an expert in an area and then informs the team on, for example, neural networks. Or in my case, I'm really not an engineer. I'm not a professional programmer, but the programming that I've become good at enough to keep up with the team, if you will, and inform the team what my designs are, is MS SQL or SQL. That's been absolutely essential as a programming language to inform my designs. So that, to me, is how data science relates to application development. So.
I do want to say, I wrote a book on the chat. I don't know if you got a chance to see it, but I think of it as, there's this book, Weapons of Math Destruction. And the reason why I say this is I was thinking about, John was talking about machine learning. So kind of like in a summary, so the author emphasizes, is the light, the importance of reducing bias in machine learning, right? Because it can hurt people, it can hurt good people. So if machine learnings are going to be used for people, you have to make sure that those people are being well represented in those machine learning models. Even if it comes like models like that predict who's going to be able to get out a loan or a mortgage or those kinds of things. So it's critical that we have people that are in our data scientists that are in one way or another are helping making sure that we are well representing people in those machine learning models. But then I would say it looks like we're moving in a digital world even more than before. So we know that businesses are collecting a lot more data. So we need people to be able to do something and provide some meaningful insights from that data. So yeah, I mean, data science, from what I heard as well, it's not going anywhere anytime soon. It's just growing. And also data science, it's such a huge term. There's so many paths that you can take within data science. Like the more general ones are like machine learning engineer, data engineer, so somebody who collects the data and it prepares it for the data scientists who are building the models, or there's also data analysts that are creating the charts to see if there's any like insights from there. So there's so many and then like within those jobs, people branch out to do different roles. So like, yeah, data science is not going anywhere, and there's just so many paths within data science that you can take. So that's what I would say. And let me just turn on these lights. But yeah, that's it.
Hearing about this is something that for me is really like bringing a lot of lights and light bulbs in my head for sure. Just thinking about it, how everything really is ran by data in this world, especially with now just like so much of our data being collected as well, and just seeing how a lot of that just influences just the world we live in. Janet, this question is a little bit more for you. Being a woman, being a Latina in tech, right? Did you experience imposter syndrome? And if you did, what was that like for you? And what advice do you have for people who may face that entering the tech field?
Yeah, I mean, I would say I still feel it. I spoke with people that it's a natural thing, and you will feel that. And I mean, this is my third day, so I can't like I still don't have months and months in this field, so I definitely feel that. And when I was starting TKH, I also felt it. I was like nervous. I kept on asking myself, oh, like what if I can't keep up? What if I'm like bringing the class down because I'm just not keeping up with the material? But I would say that like it's really hard, but you have to I mean, I don't know how to put it, but I just try to push those thoughts aside, and I just try to focus more on my learning path and my learning growth. When I was like, for example, when I was a student, I was constantly pushing myself. I was constantly meeting with mentors. And that's something else, like having mentors really made a big difference for me, because especially somebody in the field, I put myself in that position where I would be like showing my skills to this person, even if I felt like they were not good enough. But to hear them say, like, you're going to do great things, like, oh, you're learning this so fast, from somebody who is in the field, I think that helped me a lot. And it like just reminded me that I can do it. But also, I would say what helped me is that I had amazing peers. I had like my instructor would always say, you just have to be uncomfortable in the unknown. Like you won't always know everything, and that's completely fine. But you just know that like you probably know you're gonna know enough to do the job. But like you're always constantly learning, and that's what this field is about, and that's what I've learned. And at least with Bloomberg, what's really helping me is that like I have people who understand that, that I'm just starting my career. They're there to help me. They're constantly saying that I should ask questions if I have. They're teaching me all these things that I need to learn. So it also makes me feel comfortable to be here. So I think what also matters is to be in a safe environment to learn. And I think that kind of helps me with those nerves, with like those thoughts of like, oh, I'm not good enough to be here. But again, knowing that there's people there that are gonna support you and help you, I think helps me to push those thoughts away and know that I can just focus on my learning, because at the end of the day, you are learning, you're just starting your career. And always welcome feedback, always welcome, help from others. Like that's something that has helped me. But again, number one thing is to remember, like you're starting your journey, and we all have different journeys. We all start our careers like at different times. Like I know some of my peers started, working in tech before me. But again, you all have your own path to get to the tech space. So those are some of the things that helped me push those thoughts away.
That is amazing and beautiful to hear. And I think you touched on something that really leads into my next question, right? Mentors and the value of mentors. Here at the Knowledge House, something that we really make sure and really pride ourselves in is making sure that our fellows have the opportunity to meet with mentors, not just to work on tech things, but also just basic career things, right? Those mock interviews, resume building, cover letters, and just having conversations, like Janet said, about being in the space, what it really looks like and what it's been like for them. Janet, you already shared a little bit on it, but John, did you have any mentors coming into this space? What was it like for you?
That goes back to the question you asked earlier about what would I do differently. I just thought of one as that would be to develop not only one mentor, but it's really a group of people, maybe more than one person, that you can talk to about what you're really interested in. Because when you go to work somewhere, they want you to perform your job, but that there's a little line that's your own side of the line, which is why you're there, why you're doing the job, what motivates you, and then what might put you off. This imposter syndrome, for example, is a very good example of that, or doubts you might have, or areas you might wonder about studying. And having a mentor, one or more trusted people, you can say, I'm wondering about this, I'm thinking about this. That gives you a person who sees you and can identify your strengths and tell you what you might want to improve on. And that kind of dovetails into one other comment I want to make, which is about the so-called soft skills of a career, which I think are so important. And that's what a mentor can really help you with. Get to know someone, or consider getting to know someone who can tell you what they really think. Like, you really ought to consider changing this about how you come across this way or that way, or I would change your resume to do this, or maybe it's your the way you're preparing your professional attire to go to work, things like that. Because these little things that you could say are maybe in our blind spots are the things that we don't want to trip us up. We want to go into our jobs remembering that that's a place where, thankfully Janet's encountering a lot of friendly, supportive people. But I think I'd like to hear what Janet says about this. We always remember that a job is a place we go to perform a specific task or set of tasks that we were hired to do. And it's not primarily a place we go to make friends. Do you see what I'm saying? And that can be a little confusing at times. And keeping a smile on your face, but making sure that you're staying objective, I think is a balancing act that requires a mentor to help you with. What do you think, Janet?
Yeah, no, I definitely agree with everything you said. And I was just also talking about my mentor, and like what I love about, as I mentioned, TKH, is that they provide tutors. So though, even the way that it happened, actually, I just went to this one tutoring session. I needed help with it, and I really felt like we connected. Like, the person was very welcoming. He was very, like, he was great to talk to. So it wasn't that like I asked him to be my mentor. I think I just, like, because it was so easy to talk with this person, obviously very knowledgeable. I felt like that relationship started building on its own, that like little by little, I started asking him, like, hey, can you look at my resume? Maybe I want to make it look more like a software engineer. That would be great if we can do that. Hey, can we study like together, because I have like interviews coming up. So I think, like, once you start building those relationships, you find yourself like asking these questions that then little by little like help you move forward in your path. And sometimes it's not even like, you don't even ask the person to be your mentor, it just happens naturally. And I think that's the best case scenario that happened to me. And it was just, again, I just went in there, I needed tutoring help with some project, and I felt like I got so much out of that relationship. So yeah, I really, again, like, the reason why I'm here is like because this person just motivated me, and like he believed in me, and therefore, like, I started believing in myself. And I would say the number one tip the person said was, when you're applying to jobs, and if you feel ready, if you not necessarily qualify, but if you like you fit most of the description, but you're having these doubts about whether or not you should apply for something, like my mentor said, like, let the company decide that you're not ready. Like, don't do that yourself. So I feel like after that, I just said, you're right. Let me submit my application to Bloomberg. The worst case scenario is just they're not gonna get back to me. And I did end up getting those interviews. And if it wasn't for that push, like I feel like I probably wouldn't have even applied until much later when I thought I would have been ready. So it's so important basically is to have a mentor is what I'm trying to say.
That is amazing. I really like that line. That's definitely something I'm going to keep in the back of my head for sure. Um, and my last question for both of you is, of course, why do you think the data science track, and specifically at the Knowledge House, is the one that people should apply to?
I mean, I'm gonna be biased because I went through the track, and I I loved it. I had such a great time because um the instructor was amazing. I felt like even though it was 4 hours of just being in the classroom, and I know it was through Zoom, but I genuinely enjoyed being there. I was also the kind of student that would always be asking questions. I would always have my hands up ready to answer or to ask questions. So and I think my peers were also really funny. They would always crack jokes. But it just felt like we had a safe space to learn. And I think that's what I realized about TKH is that they do provide instructors that will create that safe space for you. And of course, it's about you and making sure that you also put in the work and that you're also being present in the classroom. But that's something that like what I really love. And again, having been there for 4 hours and I was like just loving constantly learning there. And having such a great time. Like I was really sad when we graduated because I knew I wasn't gonna see my my peers and that I wasn't gonna be learning with them. But that's something that I loved. And also it just feels like a family. I mean, you're basically from September to June, because then you do your internships. But you spend a lot of time with TK8. So I feel like they get a chance to know you. You have a case manager. So you speak about your process, but yeah, your progress through TKH, but also how you're doing outside of that and anything that could be, preventing you from moving forward. But I genuinely feel like they care about you. It does feel like a family. And also they have so many resources, again, tutors. It's such a huge difference. Like I can't emphasize that. Like the mistake that I made when I first started with TKH is that I would try to learn things on my own, but it would take me for like hours to try to code. And of course it was a good process, but it wasn't until I started going to tutoring and like I started learning so much, like because the tutor would say, okay, this is great, but let's see how we can optimize this work that you've done. And I feel like that's when I started learning, truly learning, and much faster than how I was when I was doing it on my own. So I would say overall there's just so many resources, but number one thing, it genuinely feels like a family and people really care about you, and you also have months to learn and grasp these concepts instead of doing it for like 2 months. So that's something that I genuinely love about being here at TKH.
Amazing. Thank you so much, Janet. Before I go ahead and open up to everyone else, John, Janet, is there anything either of you would kind of just want to share with the audience right now, anything at all, and just give insight on?
The one thing I'll say about why someone would want to or should consider data science as opposed to say they didn't want to do it or don't want to do it or feel intimidated or not interested in it is that if they look back at their own TKH path to success assessment, which I love that concept. I wish I'd had a path to success assessment when I was about to go to college. It would have helped me. And I love that you guys are doing that. But one of the points in the path to success assessment is to see how TKH fits into your goals and plans. And I think that my message would be to look at your goal and your plan and then I'll use the term reverse engineer, say from my goal and my plan, do I really have a good sense of the data that will inform my application, my interests, and then study data science with that goal in mind. And that way you'll have a more, I think, a happier journey towards application development with or without formally committing to data science as a track. You're definitely going to need data science to help you be a good member of the application development team, is what I would say.
I think what I would say is, like, if you decide to go to the data science track, I think what's really nice about the tech space is that you always have the chance to like change into something else. If like, let's say you decide that you want to try a different specialty, there we go with the lights again. But as you can tell, like I went in there, I did the data science track, but there was a point where I realized that I was more interested in the software engineering than I was data science. But of course, like people, it's a normal thing for people to go back and forth though. But I, towards the end, I remember thinking, oh, I want to know how do I gain these skills to learn software engineering, because I did mostly data science and I found a way to do that. So I just know that I feel like going through the data science fellowship gave me the foundation to start my career. It gave me the tools to be able to go from data science to software engineering. So that's what I love. But of course, if you are somebody who, very interested in data science, of course, this is a great place. As I mentioned, even if it's 1 year, you do have the time to learn, versus like having it in 2 months. So that's was something that I like really, really liked. And the fact that it's part-time, it just gives you the chance, like, again, if you need to work, because I understand, we got to pay the bills, but know that you will have a lot of support to go through this program, like a lot of support. So yeah, that's pretty much, but yeah, any questions, I'm here.
Amazing. I'll pass it off to John. I know John has a slide deck that he's going to share with us. So you can go ahead.
So when I was starting my university career and then leading into medical school and then research and all of that, the thing that interested me the most was I wanted to know why, and I wanted to know how something was applied to anything. I just wanted to see the real world application. So that's kind of, I want to breeze through some slides to show you what we're actually doing with data science, as opposed to what I think about data science or my opinions. So I'm going to run through this set of slides, and Camila will probably need to stop me because I don't think I'll make it to the end of this. But this is a graphic I found in an article about what data science is, because I myself wanted to know, what does the world think data science is? And I looked at this and I thought, hacking skills, machine learning, math and statistics and knowledge and danger and traditional research and substantive experience. And I thought, how did I ever get into data science? Like, is that what I'm doing? And then so I kind of had this reaction to that. And I wonder if Janet has that reaction sometimes to what she sees in the real world. So to me, again, I'm bringing up the concept of reverse engineering, which to me means the real world or your own interests, and anything I or you are interested in as a person, I think we can master the skills and the techniques needed. That's my theory. So in my case, it was a hospital. That's where I ended up. That's where my medical career happened. And a hospital has lots of problems. Its main point of business is to take care of a patient. And the way a hospital keeps track of their success, at least financially, is they have revenue, they have expenses, and they want, at the end of the year, a positive margin or not a loss, let's put it that way. So that is the domain of financial accounting, to understand that. But when we talk about what about all the hundreds and hundreds or even thousands of healthcare professionals who take care of patients, and what about the staggering number of medicines and techniques and tests they use to take care of a patient, there's just a big, gigantic question mark. And that's where my experience, I could say, diving into data science in the second part of my career happened. I wanted to know answers to how efficiently are we providing care, you could say, at the bedside. That was my question. And the guys in the financial accounting said, what? What are you talking about? We don't know. I mean, good luck. And so I began to program and write applications that could answer questions of interest to me. When we're looking at that from a data science standpoint, the answering questions like how efficiently or productively are we providing patient care, it's a question of IT system integration from multiple data sources that I've listed here. And then the data that come out of systems like that can be in all kinds of different formats, ranging from strings, binaries, all the things you've been studying or will study, time series, geospatial data. And so those things were important to me to understand because I wanted answers to questions that didn't seem to have good answers. So this is when I think of data science, what I'm referring to in our case is what's called operational accounting as opposed to financial accounting. So data science helps us develop algorithms that then inform our application. So my sense of what data science is on the right side of the screen, not so much on the left. This is what the patientsDB system looks like at the login screen, just so you know, this is actually an application. And here's the homepage with a set of options on the left, and then a homepage dashboard that shows you your entire hospital's performance. This is called a trailing 12 months analysis, which is automatically updated all the time. And previous means a year ago, current means the last 12 months, and then the trends. And these are the kinds of metrics and dashboards and automatic answers that I was looking for way back when, and they just couldn't give me these answers like this. So if you're in the hospital and you're managing, for example, an operating room, the surgical area, and you have a complex set of procedures to perform every day, a bunch of people, a bunch of patients, and you're wondering, are we making a positive margin on the cases we're doing? That ends up being a consideration of all the instruments and devices you're using, the treatments and different infusions you might be using, and then a whole array of teams that change and evolve and change every time you do a new procedure. So another example would be, what if your hospital is interested in buying a new MRI scanner? This is a $2 or $3 million investment at a minimum. And you're interested in knowing, is there going to be a positive return on that large expenditure of capital? That's called a return on capital analysis, or return on invested capital analysis. And so you're going to have to consider all kinds of things like electricity, since an MRI machine uses an enormous quantity of electricity. You need doctors and people who understand how to interpret these studies, the technicians who support the machine, and you're probably looking at a bank loan and some depreciation on a machine like that. And so these are all of the considerations that need to go in from a data science perspective. And so all these things are things I looked at. And one of the outputs, if we do our data science correctly on that, is a hospital might ask, how many years do we have to wait to get to what's called a break-even point on our investment? And so in this sense, you can see that this scanner breaks even on that let's say a $2.2 million investment at about 8 to 9 years. And that's very useful for them to know. And so that's an example of something we focused on. Another example might be a rehab or physical therapy department, where again, you're dealing with the same question of, we make some money, we have some expenses, but do we really understand what we're contributing to the hospital's overall margin? Because we have all kinds of therapists in a let's say a complex environment giving these procedures or therapeutic procedures to the patients. And one question that we could help answer is, how many procedures or patients does one therapist need to see in one shift to break even on their costs? And we can see that we get to that point around 6, 7, 8 patients. That's the minimum a therapist would need to see to make sure they're covering their own costs, their salary and benefits. And then after 7 or 8 or 9 patients, you can see that goes to what we call contribution margin, which is the blue part coming up here. That's the part that's left over to reinvest in new equipment or additional hires or things like that. So these are what we call, again, operational accounting answers based on data science. The tools that we use in a day, I wanted to show you a little bit of that. We use agile software development. We have what we call an issue tracker or a ticket tracker, where we manage our software development. And this is kind of just screens that show what we see every day. We manage it this way. We see details about what we're trying to do on a given effort. And we're telling each other, is this ready to, is it a new problem, assigned, resolved? Is it on hold? We need to verify at the staging platform, or it's time to move to production. This is the way we communicate with each other in an agile development sense. Here's how we develop a new ticket, a new project. We select what application or what part of the system is it coming from, the dashboard, administrative sections, or anything else. And then we say, from what table in the database is this relating to, if we can specify that. And again, what stored procedure or data science code is relating to this effort. What priority is it? Is it low priority or normal or medium or urgent? That tells your engineer how urgently we need to work on something. And then, is it a bug or is it just a requested change? That's how we communicate with each other. We use Amazon Web Services extensively. As a small company, we need affordable, powerful tools that scale to where we are, and that's been extremely helpful. So this is just a view of what we see when we use these tools, and I thought it might be useful for some of the fellows to see what we use and what we see. So this is AWS. This is remote access to a client site, as this is what we see on a platform that was provisioned for us to provide patientsDB. And what you see here is a browser platform, and the red underline shows these 2 versions of patientsDB. On the left side, PDB Live means the production system, and then PDB Test means the staging or test environment. And so here again is the application. This is one of the screens that a user would see to produce business intelligence reports. This is what it looks like. I wanted you to see that. Here's a result. And this is just, I'm just streaming through this so you can see, what does this even look like and what are we dealing with? And if anybody has any questions about what you're seeing, if I'm going too fast, just email me and I'll answer questions for you. But what users want is not so much to know about your data science. What they want is an answer. They're busy, they're seeing patients, they're on the job. They just want answers. So our answers have to be fast, but they also have to be accurate. They have to be correct. So this is drilling down into details that they want to see at the patient level, the one I was referring to earlier. This is what I referred to about the geospatial data that we're dealing with. There's a large effort for hospitals to look at marketing data now. They want to know where the patients are coming from. And this is a tool, this is a Google Maps API that's extremely helpful to a small company like ours, because it gives us the power of a large company to be able to show amazing results like this, where they can look and see immediately, for example, in this zip code in California, what patients came for which services and which number of patients, for example. This is another screen that shows kind of, you could say, data transparency. We want the users to be able to see where do the data come from, and this gives them transparency. We want them to see very clearly that if we're dealing with millions and millions of dollars, that we're not losing it, or they can explain it to their bosses. This is what patientsDB did. We can trace the result back to its source in a data science sense. That's what this is about. It's about validating the data sets. Graphics and visuals are very, very important, as I'm sure all of you know. We use Chart.js, which is a very, very flexible and affordable powerful tool for a company like ours to be able to show trends and visuals that would otherwise be just kind of grid tabular reports. This is another screen in the system that is meant for the user to be able to dig into the question of validation. So this is called a validation log here. And this, every time we run an extraction procedure to get new data, we validate it between source and destination. And we're looking at variances. And the variances are intended to show you, are you off? Did patientsDB make a mistake anywhere? And if it did, if the variance is largely positive or negative, we look into it right away. So this is kind of like a meter that helps us understand whether we're on track with our system, because numbers are easy enough to come by, but I think Janet would agree with me. Let's make sure we're on track, and that's what validation is about. I mentioned databases and SQL before. We're running a very, very large relational database. SQL Server is the database engine we use, and it's absolutely essential to not only the data science, but again, the application development. This is what SQL Server Management Studio looks like to use. I'm just going to breeze through this. And again, if you have questions, you can ask by email. But this is what it looks like to look into the brains or the under the hood of a big application like this. We run queries. I run queries myself when I'm looking into data validation question. This is an example of a query in a text file. I'm going to paste it into the SQL Server Management Studio query window. That's pasted now. I run the query. This is looking into the data at its source. I want to know what's going on. I'm looking at the data, right, one-on-one. And I'd be interested to know what Janet thinks about this. But I use, for example, Excel. I'll take a Microsoft SQL Server and SQL and grab the data. I'll paste it into Excel and look at it just visually. I want to know, what is this showing me? That's one way I stay in touch. On my local machine, this is looking at my local desktop. I have tools here where we manage different parts of the company as well as the system. So I have project management, I have backups, and I have other things. Here we have specs, specifications, we have documentation, other testing. And here I have a diagram of, it's called a schema. This is relating database structures so that I can quickly refer to them and see what relates to what and how I might be able to build new code, new applications, or I might be able to debug something more quickly if I have these maps available to me. Here are just this is just a look at the directory where I keep a whole series of specifications, just so you can see what this looks like. Here's another validation tool I use. Again, it's based on Excel, but this is where I've taken what a user would see as a report, I've pasted it, and now I'm going to go into extreme detail to make sure patientsDB isn't having a bad day, because a bad day for patientsDB will be a really bad day for me. So here I'm looking at this term checksum. I'm sure Janet has a great deal of familiarity with that concept, is where we're looking for the checksum to be 0. And what that means is we're saying, does the destination, or in other words, the application, is it giving us what we found in the source without biasing it in a direction? And that's what that's about. Now, the last thing I'm going to say
I
again.
just want to let you know, Janet did hop off. We can still keep going, but I just want to let everyone know, if you do feel the need to hop off right now, I know we were to end at 7, definitely feel free to do so. I'll make sure to send you the surveys afterwards and any contact info as well.
Right, so I have about 20 seconds left. I want to just make a comment on data and databases. And so this is kind of a question about SQL versus no SQL. And my pun on, I think it's Shakespeare's play, is that a question? That is the question. So I want to make a comment about SQL versus no SQL, or relational versus non-relational. The way we see databases now is not so much SQL versus no SQL. This is really just a very, very large set of new database tools that are available now. And I think that any progressive web application will use 2 or more of these types of databases now going forward. And this is just a screen that shows the examples of these database types, relational being SQL Server, the one that I mentioned that we use so much. But these other types of databases, key value, wide column, document, graph, and these other types of databases, which are tending to call NoSQL, are really an array of tools that are going to become very, very important to, I think, every application, including ours. And so that's it. I wanted to leave my email address and say thanks and sorry for going over, but if anybody has any questions, please email me and I'll be happy to answer.
No, thank you so much. I think you going over, I think, is something that's really valuable, especially for the people on the call, right? I know this is something that's super interesting, and just seeing the different topics and kind of having those visuals, especially for our visual people, right?
Yep.
For me, I can hear all these things, but now that I've seen this, it really makes a lot of things click for me and it brings things full circle. So thank you so much for doing that and really making sure that people can see what that looks like. Yeah. And that is so awesome. I really do appreciate that. I know Janet hopped already. John, I know you shared our email. I'll also send that to all of our attendees here tonight too. I'll make sure to share you on that, just so you guys have access to reaching out to John if you have any further questions. But thank you all so much for joining us. I'm going to stay on for a few seconds in case any of you have questions about our application or even have other questions just in general about the Knowledge House. But thank you so much for coming today. As a reminder, we do have a session next week as well from 6 to 7 p.m. Eastern Standard Time, and we'll be focusing on progressive web development and UX UI. And of course, the week after, we will be having cybersecurity. So I definitely look forward to seeing some of you there. And thank you again for joining us tonight. And thank you so much, John, for just bringing so much insight and really providing a lot of information for our participants today. Thank you all.
Thanks a lot, everybody.
Have a good night.